Our sense of smell works much faster than before we were judged. Scientists have shown that in just 60 milliseconds we are able to detect the change of smell reaching our nostrils. It is shorter than a blink of an eye. During each breath, the airborne substances chemicals get into our nose and create what we recognize as the smells. They are expelled during the exhalation. Usually the breath lasts from 3 to 5 seconds, which led to the belief that our ability fragrances detection and differentiation is slow. Even Charles Darwin pointed out that our sense of smell is exceptionally not useful. But it turns out that with identifying aromas we advise it's much better. This is evidenced by new research published in the journal Nature Human Behavior. Scientists at the Chinese Academy of Sciences have shown that the human sense of smell can detect minor chemical changes during the duration one breath. All our senses are confronted with the surrounding world. However, nothing compares the challenge facing the sense benefits. Our noses distinguish between the enormous complexity of the chemical world, from many million odors, each of which consists of hundreds of particles, differing greatly in shape, size, and properties. For example, the smell of coffee is made from a combination of hundreds of chemical ingredients, each of which is structurally diverse and none of them smell like coffee. Olfactory receptors were discovered several decades ago, but then scientists were unable to look at them up close and decipher them actions. Partly because these receptors are not suitable for imaging for helping common methods. In addition, the pherothians receptors appear have no preference and may respond to relationships that are both structurally, as well as chemically different. Snoanoias receptors bind to a large number of molecules fragrance, or odorants. They are located in the membrane cellular receptor neurons of smell. The variety of aromas it makes each receptor respond to many chemical components. The brain can recognize the odor, taking into account the pattern of activation of the receptors. Dr. Zhou Wen and his team discovered that our sense the smell works much faster than previously thought. Intuitively, the smell it seems like taking pictures of a chemical environment with a long time illumination, Zhou said, adding that when the smell is detected, maybe it seems like one smell, not a recognizable mixture of aromas that they appear at different times. Scientists analyzing smell have developed a special device consisting of two tubes of different lengths connected on one side, two containers with different odors, and the other with a nose, from which there was aroma. Different length of tubes allowed to present different fragrance substances in precise order in time counted within one breath. Researchers chose the length of the tubes so precisely that the device it supplied various fragrances with an accuracy of 18 milliseconds. Millisecond equals it is 1/1000th of a second. Scientists made fragrances, presenting two odors one after the other with precise time intervals. They invited to the research 229 people. In total, they prepared 5 experiments to see if participants they can distinguish the mixtures developed. In one experiment, the participants were presented with a smell the apples and flowers. Approximately 120 to 180 milliseconds after the first smell into the noisy of participants the second came. The task of the respondents was to smell the camera twice and answering whether the order of odors was the same or state it's changed. Participants responded correctly in 63% of cases. When the smell apples and flowers were replaced with the aroma of lemons and onions of the test ended with similar results. Participants who showed the best sense the ferocity was invited for further testing. It turns out they can see the difference even when the aromas were sprayed with a delay of only 60 milliseconds. It is up to you about 1/3 of the time it takes to blink an eyelid. It's a lot of time shorter than previously thought is necessary for people to be able to distinguish two fragrances presented in different order. Researchers have determined that for this the ability was not affected by factors such as the intensity of the smell, its pleasure, sharpness, or total amount of odor molecules. The participants could say that the smell changed when the odor order was changed, but it was harder for them to identify which smell appeared first. They did well in the case of smells lemons and onions, and when the aromas reached their nostrils with an average difference a time of 167 milliseconds, they also had a tendency to evaluate the overall mixture odor as similar to the aroma presented to them first. This suggests that the order of odor recording shapes our perception.